Alright, welcome to the next video. We've been working with polar ecosystems, but what we're going to do today is talk about how to deal with some of the polar ecosystem data today in a more dynamic way than you've seen before using something called RShiny. So I'm just going to make a note to ourselves here that we're going to be looking at polar ecosystems using RShiny. And you're probably wondering what RShiny is, but RShiny is a way to produce not just plots, but also dynamic plots that you can now build a user interface for, and then have the inputs from that user interface be dynamically updating your plots, and your new plots actually showing up in a web page. And so this is a way to write an app through R so that when new data comes in or data that you want to manipulate in some way, you can manipulate it in a really cool way using just your R application, and you can put things out on the internet. So a Shiny app consists of three things. The first thing you're going to want to do is, if you haven't done it already, you're going to want to install the library Shiny. And you can do that in two ways. You can write install.packages Shiny and go ahead and run that. And you're going to want to do dependencies equal true. You can run that, or you can come up in here into tools and do install packages, and that will, you can add your package in here, Shiny. There it is right there, and go ahead and hit install. You can do either one of those. But once that's done, a Shiny app consists of three things. The first thing, so I'm just going to write this. Shiny app consists of a user interface, sometimes we call the UI. It also consists of a server and something to put the server and the interface together, which is called the Shiny app. And so I'm going to show you, oops, spelled that wrong, how these things work together. So the basic template that you work with in your code is you're going to require Shiny, right? So we can go ahead and run that. There, now it's loaded. And we also need to have a user interface, and that user interface is going to use a function called fluid page, capital fluid page. And if we do question mark fluid page, this is what you get. It's create a page with a fluid layout. And what is going to happen here, let me delete this. What's going to happen is that we're going to put functions inside this fluid page which will write HTML code for us. And so we'll get back to that. So this is now creating the HTML code to hold the user interface, and we're going to get back to that. And then it also has a server, which we talked about. And the server is a function that has both inputs and output. And we'll show you how to define those in just a bit too. So what is going to happen on the server function is that it's going to be waiting for input from the user interface, and it's going to produce an output. And we'll show you how those things work a little bit. And then finally, we're going to use Shiny app to define our user interface. In this case, our UI is going to equal, it's called UI up here. And then our server is going to equal our server. And that's going to launch, that's going to stitch together both our user interface and our server to go ahead and launch our app. So that's the basic design here. So some of these things are foreign to you, that's okay. We're going to walk through an example, but if you want to see a full laid out example, you can come here. rshiny.rstudio.com/tutorial, and there's a 2-hour and 25-minute tutorial, but that's broken down into sub-apps or subsections that you can take a look at. We're not going to be doing all of these things. We're just going to be using examples, and in fact, you can go to a gallery of what these shinies look like. And let me just show you an example here. So here's one for k-means clustering. And what do we have here? We're looking at irises. Is k-means clustering? What does that mean? It's just a way of clustering data together with sepal width. So it's like a little leaf, a special leaf on the plant, and the sepal length. And we can change our x and y variables, and we can cluster our data in 4 clusters or 5 clusters, and you see that now we get individual clusters of data breaking out. And this is what this looks like. So here's the UI, here's the server, all these things in here, and then it produces this. So what's going on? So I am putting input into my RShiny app. So I can do petal length, say here's petal length versus sepal width, or I can do petal width, and create clusters here, and it's showing me, how the different clusters are, how different groups are arranged. I can change the number of clusters here to 2, 7, right, 8. See, I can go down 6, 5, 4, 3, 2, 1, and so what's happening is that I'm sending commands back to a computer somewhere that's running R, which is then updating these plots and then showing it to me in a web page. That's what we're going to do. So, in short, what's going on? I am using a user interface. I'm changing the inputs, and it's giving me an output over here. So if we think about what's going on in our code, again, this is our server is going to take inputs from our user interface, which you just saw, and produce an output, which is graphs in this case, and this Shiny app stitches it together, puts it on a web page for us. So that's what we're going to do. So before we do any of this, we need our Polar Ecosystems data. So let's go ahead and go back to reading in sea ice data. Right? So remember that. We're going to type sea ice equals something. This was all in the last video. Read.table. We want, what I'm first going to do here is, remember, set my working directory to the appropriate one. So this is where my data is sitting. Okay, so I'll go ahead and run that. And I'm going to read.table 2015. If I tab this out, I'll probably be able to find my file. There it is, 2015.825. That's our file, sea ice file. Skip equals 14 if you remember, and header equals true. So this is all what we did in the last video. And remember that we needed to find sea ice year. In this case was 1980 to 2015. And our amber days with ice, IDY, sea ice, IDY. So let's go ahead and set this and read this in just to remind us. So I look at the head of sea ice. Yeah, so remember that. This is what this looked like. We want this column out here, which was the nearshore foraging region. And this was the actual days with ice for the different years. And we can define our sea ice year as a sequence, and then also our days with sea ice. And then, just to make sure, we can go ahead and plot sea ice year. That's our sea ice data, type equals L. So let's go ahead and do that just to make sure that this looks familiar. Oh yeah, so that was the sea ice data that we had near Palmer Station in that penguin foraging area. So we have that. Let's move on to the next thing. Reading in krill data. This is going to be similar to what we did before, so our krill is going to be read.csv. Remember, it's a CSV file. And let's see if we can pull it up. This is LTER, krill. Yeah, there it is. Header equals true. And for our plots in the last one, we needed our krill year. It's going to be a sequence of numbers, was 1993 through 2016. Oops. And again, this reading in this data, this was covered in the last video. But let's just make sure that we understand it. Head of krill. Yep. There it is. There's our years, grid line, station, and our date, and we want this E superba, so we can now plot krill year, krill $ E superba number. Type equals L, and if we go ahead and run that, there's our krill. That looks familiar. And then finally, let's go back and read in the Adelie penguin data. So pen is going to be read.csv. These are the data sets you guys have been working with. Adelie penguin. Yeah, there we go. Check counts. Header equals true. And if you remember, we needed to aggregate that data. Means add it up over all these different islands and years. And so we needed to write a piece of code that does that. Our aggregated penguin data is going to be, you'll notice a couple of things here. I've been using the equal sign instead of the assignment. Either one in this case will work, but let's just be consistent. Okay. Aggregate. Let's just take a look at this real quick. We just did that. Oops. So the pen 1, 2, 3, 4, 5, 6, 7. We want to aggregate pen rows or columns 6 and 7 by something. Study name, this is here, so it's going to add it up over all the years. That turns out to be the years. And the function we're going to use is the sum. And we're going to remove the NAs. So that's going to aggregate those. And if we look at the head of ag pen, we remember that, yes, okay, there's our adults and our chicks, but our years are a little bit out of order. And just like the last video, what we had to do was come up with a penguin year, 2001, 2013, 1992, 2000. So if you're confused with some of these early codes with the data sets, what we're doing with the data, that was all covered in the previous video. And now we're going to bind on our year. Oh my goodness. So what is that going to do? It's going to stick our year on this. Oh, actually I have to run it. So here it is. There's the year. Now we want to order it. You guys remember, we're just going to overwrite this. So all this does is it puts this in order of the year. Oops. Right, and so now we can plot ag pen year with ag pen adults, and that's what we get. Right, there's our decline, just to be consistent. Okay, all looks very familiar. So we now have read in our data, and now we want to come down here to the Shiny app and ask ourselves, what can we do dynamically with this? Well, what we're going to do is we are going to add an input to the data that lags these data sets. So we're going to align them via year. We're going to say, well, maybe we want to lag or advance the krill time series or the penguin time series to try and see if these things line up in any sort of sensible way. So what we're going to do is go into our fluid page. Inside this, we are going to start adding things to it of what this thing is going to look like. So we're going to add first a title panel. So that's on the inside, and we have to pay attention to our parentheses here. So you'll notice that now we've got fluid page with open close parentheses. Now we have title panel with open close parentheses, and on the inside of the title panel we're going to type, this is the West Arctic ecosystem. Okay, comma. We're going to add something else. So remember, this one is the end of the fluid page, but we're going to go ahead and hit return, and we're going to add another argument to fluid page. So it's going to have a title panel, but we're also going to have a sidebar layout, open and close parentheses, and inside the sidebar layout we're going to have a sidebar panel, open and close parentheses, but we're going to have to also put something inside there, right? So far, if I just back this up, we have our fluid page with its closed parentheses being highlighted down below, and then here's our title panel open, and its parentheses is being closed there, so that's good. And then we have sidebar layout, which is parentheses closed there, and sidebar panel, which is parentheses are closed there. And we're going to do one more thing. We're going to do something called a slider input, open and close parentheses again. So we're going to add something called krill lag, and the description of this, so that's the input ID, there it is. The label of it here is going to be called the year lag on krill record. Alright, we need to add a min. Oops, there we go. Min is going to equal, let's say it's minus 10 years, and our max is going to equal 10 years, and now our value, which is our starting value, is going to equal 0. Okay, so that's one slider input. we're going to do this again. Do a comma, do another slider input. Its ID is going to be called penguin lag. Its comma, it's going to be the year lag on penguin record. So how many years are we going to add or subtract from the penguin record? And similarly, we're going to have our minimum be minus 10, our maximum equal 10, and our starting value equal to 0. All right, so what are we doing here? If you're a little bit lost, stay with it just for a minute. These are slider inputs are going to go on, and now we're going to add, we're going to close now sidebar panel. Okay, so we close sidebar panel, so I'm going to delete that closed parenthesis and I'm just going to put it here. So now we have sidebar panel closed. And so now, instead of in this sidebar layout, there's a sidebar panel and then there's also the main panel. Oops. Main panel. Okay. So in our main panel, this is where our main panel is going to hold 3 plots. So we're going to make 3 plots. Those are going to be the 3 plots that we are working with. Our sea ice, our krill, and our penguin. And we're going to use a function inside main panel called fluid row. And what fluid row does is it sets the dynamic placement of these plots. So inside fluid row, we're going to use the function called column. And the width of the column is going to be 12. Our plot output, this function now, we're going to have a couple plots. What's our output ID? Plot 1, we're going to call it. Its height is going to equal 200 pixels. Oops, put it in quotes now. Pixels. And this closes plot output, column, fluid row. Okay. Now we're going to do comma, and we're going to do the same thing. We're just going to copy this thing. Put the next one, fluid row, except this is going to be plot number 2. Copy the next one, fluid row. This will be plot 3. Okay. We don't need a comma on the last one here. So that closes fluid row. Right? And now we got to make sure, I can just drag this down here, that what else needs closing? This closes main panel, so I'm just going to back this up a little bit. What does this one close? This closes sidebar layout. And this one closes fluid page. So many nested functions are inside this UI thing. So if we take this and we run this, oh, we have an unexpected error. Okay, so we have a mistake in here somewhere. Let's see, what doesn't it like? Oh, we probably need a comma here before main panel. Yeah, because main panel is our next argument. Let's see if that does it. Yep, it's very happy now. All right, so what did that do? Didn't seem to do anything. So what do? We're designing the user interface between what the title panel is, the sidebar layout, the side panel, the slider input, the main panel with 3 plots on it, and then if we actually type UI, what you'll see is a whole bunch of HTML code. Now you may not be familiar with HTML, that's okay. All this is a way for a web page to interpret where to put things on a web page. If you are familiar with HTML, this is going to look very familiar to you. So that's all that is. So this is where our input's going to be coming from, and our slider input is going to be both krill lag and penguin lag, and this is the design of the web page, and you'll see in just a minute what that ends up being. So let's move now down to the server. The server. So the server is the part of the code that is going to produce the output plot. So this is why it's a function. It's going to take input as defined from the UI, and then it's going to change the output, which is going to be the plots that we've been working with. And so let me show you how this works. So the easiest thing to do is maybe just to start with a plot that we're familiar with here. Let's go ahead and set our plotting parameters. Par mar equals 3515. So this is just an example. We set our plotting margins for our next plot, and let's go ahead and plot sea ice underscore year IDY, type equals L, our color equals blue, line weight equals 3. Our Y label for this plot is going to be days with sea ice in, let's go ahead and do a line break, when origin area. And this is going to look really familiar to what you guys did in the last video. Our XLab is going to be year. Alright, so let's go ahead and just run that to make sure that that works. Yeah, okay, so that's one of the plots that's going to be output. And the layout isn't going to be exactly the same as this, but we just want to make sure that our plotting code works. And we're going to do par new equals true. And remember, for this first one, what we wanted to do was plot krill year krill e superba number, let's see, type equals L, and we needed to set our X limits here. If you remember, our X limit is going to just be the range of our sea ice year. So I'll put them on the same year frame. Our line weight equal 3, color equal red. Remember these little tricks that we had, axes equals false, xlab equals nothing, ylab equals nothing. And you remember now what we needed to do, so once we ran this, let's make sure this works. Yeah, remember that's our krill data on there. And then we needed to add our own axis. 4 and our M text, margin text. Text is going to be number e dot superba per, put our line break in here, 1,000 meters cubed, seawater in, put another line break, penguin foraging area. That's going to be on side equals 4. Line equals 4 and CX equals 1. When we do that, that should add our axis on that side. That's good. And now finally we need to add one more thing to the plot here, which is a legend. X equals bottom left. Our legend is sea ice. Krill. Line weight's going to equal 3. Our color is going to equal, let's see, we want blue and red. Okay, so if we go ahead and run that, there it is, sea ice and krill. So it looks a little wonky. When we put it into the web layout, we can go ahead and back and adjust some of these things, but I just wanted to show you that we are going to make a plot, and that's going to be part of the output. So now we're going to wrap this up in a function so that the server knows what to do with it. And we're going to call this output. Our output is going to be plot1. Remember, so output is looking for something. This plot output is looking for something named plot1. That's going to be our first row. And you'll get used to this notation in a bit. And then we're going to use a function called render plot, which is the function that's going to make the plot on the web page. I'm going to open parenthesis and open curly bracket, of all things. And then that's going to go into our par, our plot, all those different things. And then we are now going to close our curly bracket and close our render plot. I'll just do this just so you can see it. Right? So that's what's going on here. So there's our bracket being closed, and then here is render plot being closed, and then it's going to go into doing our par, plot, all that sort of stuff. Okay, so that's going to be output plot number 1. Output plot number 1. So let's go ahead and just give something a try here, which is, remember we had our server here, we had this open and curly parentheses. We're just going to take this one off, and we're just going to add it down here, and that's going to close out. I'm just going to put in here, this ends our server. Let's see if this works, just so I can show you how it works. That ends our server. So that closes, I'll just back it up here. That closes this parenthesis. You see it highlighting down here. And then we're going to go ahead and run the Shiny app. So let's see what happens here. So if we run our server now, it may look a little wonky because it's expecting 3, and then go ahead and run our Shiny app. Run. All right. Okay, so we got a couple things here. We have created, this is a R browser, but we can open this in a regular browser. Let's go ahead and open this in Chrome here. Okay, here it is. So here's a web page on a web browser with our plot, and you'll notice that it changes the size. That's what Fluid Page does. So it changes the width of these things. Here's our West Antarctic ecosystem, and here's our krill lag. We can lag the krill record, but you notice that nothing's happening to the krill record yet, and I haven't showed you how to do that. how to make that link. So we can input variables, but so far it's not linked to our output. But our server here is displaying our plots. And so what we can do is just close that out. Just wanted to show you that. And you'll see now it takes us off of this listening and it puts us back to the caret. So that was the Shiny app running with our instructions for our fluid page and also our output for our plot. Now, one thing that we can do here is go ahead and if we come back into the krill year and we want to say that what we want to add into the X variable, remember krill year is year, is we want to add an input. And our input is called krill lag. And where are we getting that from? Well, if you remember, when we come back up here on the fluid page, our slider input is going to be called krill lag, and that's going to be set by the user interface. And that's going to be a slider where the user can input a value, -10 to 10, and now we're going to add or subtract that to the X value here of our krill data. So if we go ahead and run the server again and then the Shiny app and run that, you'll see now, since we've added that in there, I can move the krill record around by several years. So I'm adding 10 years, moving it forward in time, 7 years, moving it backward in time, 8 years, and I can move this back and forth to answer some questions. Okay. All right, and that's the dynamic element of our Shiny in this simple little system that we're dealing with. So we can go ahead and close that. So what do we have to do now? Well, we have to fill out our other two outputs, right? So we have two more plots that we want to put in here. They're the same plots that we had before. So let's go ahead and do that. So let's come in here, and we can, I think, copy a lot of this. Go ahead and well, let me just start by doing this. This is going to be now output $plot2 equals render plot. This is the next plot that we're going to render, and we need that. And now we're going to do the same thing. We're going to pick our par, right? We got to do that. We got to get our plots. And what are we plotting this time? Well, we're going to plot sea ice year, just like before, right? That seems to make sense. And then we're going to add another plot on top of it. Right? Okay, so we're just going to copy and paste that. And now we're going to add we're going to plot now our ag pen $pen year. That's our X values for our penguins in this case. And our ag pen $chicks. Right? That seems right. Type is going to equal L. X limit is now going to be the range of our sea ice year, just to put everything on the same page. Our line weight is going to be 3. Color is going to be gray. X lab is going to be our nothing like that. Y lab is going to be nothing again like that. And our axes is going to be false. So let's just test this out. We can just take this par in here and let's just run this. Oh, I'm missing see this little error that it's telling me here? I'm missing a comma, so I need to, and I don't have an M either. So let's go ahead and run this first part. So far so good. There's our sea ice, par new. Let's go ahead and add, there's our adults on top of that. And we also want, I'm sorry, not our adults, but that's our chicks. We also wanted to add our chicks, but, or I'm sorry, our adults. Well, we can just take this, copy and paste this, and we want this to be adults, right, I believe. But we don't want this to be plot. We want this just to be points. I'm sorry, I want it to be lines, because we want to put a line on there. Lines. Let's see if that works. There's our line. Oh, we don't want it to be gray. We want it to be black. Try this one more time. From the top. Well, not from the top, but from the last par. Okay, it's looking good so far. And now I need to add a axis on the fourth side. Do that again, and yep, there that is. That's good. And text. Adults and chicks. Side equals 4. Line equals 3. 1. And so we got 3 lines on here. So it's sea ice, Adelie adults, and Adelie chicks. Line weight equals 3. Color equals blue. Sorry, this has got to be a concatenated vector. Blue, black, whoops, gray. Horizontal, false. Box type equals N. Does that do it? No. Okay, so you see this parenthesis being closed here. So I forgot to add close parentheses here, so that's good. And this is also telling me we have a problem here. Side is not $, it's 4. Okay, it says I have a problem here, but that's just because I haven't closed the render plot down yet. So let's see if this works sensibly. Yeah, okay, we're going to get something like this. And it's going to look a little different when we put it in our web page layout. So we'll leave it like that for now. And we will then go ahead and close our render plot function right here. See that? Close those two. So that's another one. Now, just like before, we haven't moved any of our lines around yet, or we haven't made a place to put dynamic input yet. So what we're going to do now is go ahead in our X value for our chick data, we're going to add in our input from our penguin lag. Where does that come from again? Well, that comes from up here, and we defined a slider input called penguin lag, and that's something that's set by the user interface here. And so now that's going to come down into here, and that's going to add or subtract onto our years for penguin lag. And we just need the same thing for our adults. Same sort of thing. Okay. I think that's going to work. Let's go ahead and give it a try, see what happens. Yep, there it is. And you can see we can move the penguin record around. That's good. Okay, good. Okay. And we just got one more to do. Oh, we got some warning here. Warning axes is not a graphical parameter. Where are we having that problem? Plot. Maybe it's in our second plot. Oh, in our lines function here, we have axes equals false. But we actually don't need that because lines does not recognize that. So we'll take that out, take that warning away. Okay, and then finally, we need to put one more. Remember, we had three plots here that we were going to put out, so let's make our next output plot 3. And this is going to be really similar. I'm going to do render plot. Let's take those off for now. We know that we got to close that up. And what are we going to do here? We want to plot now. Let's go ahead and put our krill plot in here, but we already have that code, right? Well, actually, we already have some of the code here. Let's go ahead and take our parmar. And where did we plot the krill code? Here it is. Plot. Okay, there's our krill code. And one thing that we said here was we wanted our axes to be false. Let's go ahead and make that true because that's going to be our base plot. And we just need to add our Y label and X label to this. Our Y label is going to be, what's our label? Y label, I'm sorry, X label is going to be year. That's along the bottom. And our Y label, we're going to pull from our previous M text with krill. Here it is. That's going to go right here. I think that will work. So we just run this. Oh, input not found. Oh, yes. Okay, so we're getting an error because we're not actually running in the Shiny app server. But I think it will work. In fact, we can just test that. So let's just take this krill lag out here a minute, but we'll put it back in. Just want to make sure that the plotting function works. Yeah, okay. I can just do a Control Z, put that back in there. Looks good. Okay. Now we need to add, what do we need to do? We need to do par new equals true, and we want to add our Adelie penguins on here. That's what we just did. So here's our chicks, here's our adults, and all the M text that goes along with that. Same exact input, and now our legend might be slightly different. So let's go ahead and take this legend and we'll just edit it. But it's not going to be sea ice in this case. Let's go ahead and do Adelie adults, Adelie chicks, and krill. All right. And now it's not going to be blue, black, and gray. We're just going to move this over since krill's are the last one that we're displaying here. It's just going to be red. And I do believe that will do it. I do think so. So we have ended our render plot, and what do we have? We've got the input here for the krill, we've got the input coming in for the penguin lag, and if we put this all together now, let's go ahead and open this in a browser. Yeah, look at that. We can move krill records around, which is what we're doing there, forward and backwards. to 10 years, and you can move penguin records around. Okay, so this is a nice dynamic way to interact with your graphs that you should be happy with. So you can now run this if you want, right? Right now we're using your own computer as its own web server, but there's nothing stopping you from setting up your own like we showed you earlier, and you can put this on the web, and we can also give you some other examples with sea ice, and I think I'll post that code on the site for you guys.